Let's discuss the code implications of running multiple medium voltage cables, specifically multiple motor feeders, within the same raceway. The core reference is National Electrical Code Article 300.37b, which directly addresses this scenario. When you have two or more motor feeders installed together in a single raceway, it's essential to adjust the allowable ampacity, or current carrying capacity, of each motor feeder. You must make this adjustment according to the ampacity adjustment factors provided in NEC Table 300.5. Alternatively, you can apply the provisions outlined in 310.15b3, which offers rules for conductors installed in raceways. Keep in mind that Table 300.5 specifically provides ampacity adjustment factors when dealing with conductors located within multiple raceways, so ensure you are selecting the correct adjustment factors. Derating is a crucial consideration. Yes, running multiple medium voltage cables within the same raceway necessitates derating. This accounts for the reduced ability of the cables to dissipate heat when they are bundled together. Heat buildup can reduce the cable insulation lifespan and increase conductor resistance. The ampacity adjustment factors from the aforementioned Table 300.5 or Section 310.15b3 are used to perform the derating calculation. These factors reduce the allowable current for each cable. From a practical standpoint, routing multiple medium voltage cables through a single raceway is generally not recommended. The required derating can significantly reduce the effective ampacity of each cable, potentially requiring larger conductors than would otherwise be necessary. Furthermore, installation and future maintenance become more complex when dealing with multiple heavy high-voltage cables confined within a single raceway. Separating each medium voltage cable into its own raceway is typically the preferred approach. Beyond the NEC regulations, several additional factors warrant your attention. 1. Voltage drop. The presence of multiple cables within a raceway can contribute to increased voltage drop along the circuit. This is due to the combined impedance of all the conductors within the raceway. 2. Cable insulation. The selected cables must possess insulation ratings that are suitable for both the voltage levels and the anticipated temperature conditions present within the raceway. This is vital for safety and reliability. 3. Raceway material. The material used for the raceway itself must be appropriate for the voltage levels carried by the cables and the operating temperatures expected within the raceway. Consider factors like corrosion resistance and mechanical strength. 4. Accessibility. Ensure the raceway system is readily accessible for periodic inspections and necessary maintenance tasks. This allows for early detection of potential issues and facilitates repairs.